Hi friends, welcome back to my channel. So now we have reached the last topic of the chapter pair of linear equation in two variables, the third chapter, and the last topic is equations reducible to a pair of linear equation in two variables. Now before we dive into the topic further, subscribe to my channel if you have not and watch all my previous videos. You will be able to gauge as to what all I have taught in my tutorials so far. Share it with your friends. Also, do not forget to hit the bell notification icon so that you are updated with all my upcoming videos. And now let us dive into the topic. So now, as the name suggests, reducible to a pair of linear equation means the equation is not a linear equation in two variables, but it can be reduced to that form. So for that, again, let me take a very simple example. The first example question from the exercise 3.6. As you can see here, if you look at it at the first glance, it looks like it seems to be a pair of linear equation in two variables because it has both the variables x and y. But if you try to delve into it a little further, you will recall that in the standard form of a linear equation, you do not have the variables in the denominator, because if the variable is in the denominator, then when you reduce it to the standard form, it actually becomes x to the power of minus 1, and you cannot have a negative power to a variable in a linear equation in two variables. So which means this is not a linear equation. So let me write down the first question. Exercise 3.6, question number 1, first part. 1 by 2x plus 1 by 3y equal to 2. This is my first equation, and my second equation is 1 by 3x plus 1 by 2y is equal to 13 by 6, second equation. So remember that I am not calling it a linear equation in two variables. However, now if I assume let 1 by x is a and 1 by y is b, then what happens? I get my first equation reduces to 1 by 2a plus 1 by 3b equal to 2. And if I solve it a little further to bring it in the standard form of a linear equation, so I find the LCM, or my LCM is 6. So this gives me 3a plus 2b equal to 2, or 3a plus 2b is equal to 12. So now this is a linear equation in two variables. So let this be equation 3. Similarly, for the second equation, taking this value of x, 1 by x, and this value of 1 by b becomes 1 by y becomes 1 by 3 also 1 by 3x a plus 1 by 2 b is equal to 13 by 6, or we'll bring it in the standard form. So the LCM is 6. This will become 3a plus 2a plus 3b equal to 13 by 6. 6 cancelled, or 2a plus 3b is equal to 13. So now this is my fourth equation, out of which these two are linear equation in two variables. So you have seen that I have reduced the given equations to a form which is linear equation in two variables. And now we can solve this pair of linear equation by any of the three methods that we have learnt in the previous 3 videos. So suppose I take the substitution method. From 3, 3a plus 2b is equal to 12, or 3a is equal to 12 minus 2b, or a is equal to 12 minus 2b by 3. Now putting this value of a in the fourth equation, what do we get? We have taken this value of a from the third equation, so we cannot put it into the same equation. We have to put it in the other equation of the system. So the other equation is the fourth equation. So putting, you can also write substituting putting this value of A in equation 4, we get 2 into 12 minus 2b by 3 plus 3b is equal to 13, or 24 minus 4b by 3 plus 3b is equal to 13, or so if I separate the two parts, so I get, this gives me 24 by 3, that is 8 minus 4 by 3b plus 3b equal to 13, or I'll do it on my other side, or minus 4 by 3b plus 3b is equal to 13 minus 8, or minus 4b plus 9b by 3 on cross multiplication is equal to 5, or 5b is equal to 15, or b is equal to 15 by 5, that is 3. So now we have got the value of b, but in the question we have to solve for x and y. So we'll put this value of b back into the equation. This we did not name, sorry. So let us name it as equation A and this to be equation B. So we'll put that value in equation B. So putting b equal to 3 in equation B, we get 1 by y is equal to b, or 1 by y is equal to 3, or y on cross multiplication is 1 by 3. So this is the value of y. So if b is this, let us find the value of a. Just by substitution we have got b. So let us also find out a. So we'll put that value of b in one of the two equations, that is equation 3 and 4. So let us put it in equation 3. So putting b equal to 3 in equation 3, we get 3a plus 2 into b is equal to 12, or 3a is equal to 12 minus 6, or 3a is equal to 6, or a is equal to 6 by 3, that is 2. So we have also got the value of a, and now we need to find the value of x from here. So again we'll get back to equation a. So putting, it's a little lengthier because you are going to do this twice. A equal to 2 in equation a, we get, equation a is this, we get 1 by x is equal to a, or 1 by x is equal to 2 on cross multiplication, x is equal to 1 by 2. So we have got our values of x and y. And now the final statement, as always, very important. Therefore, solution of the given system is xy equal to half, comma 1 by 3. So I hope this method is clear to all of you, and now you are ready to do the final exercise of this chapter, that is exercise 3.6, and complete all the questions, try all the word problems using this method. Once again, if you like the video, then give it a big thumbs up, like, share and subscribe, Hit the bell notification icon to be updated with all my upcoming videos. Follow me on Instagram. Until next time, love and enjoy the beauty of mathematics. Bye.